So I thought it would be fun to see some of the taxonomies that were submitted by the students, and maybe you could see each other's taxonomies and see how these organizations are structured. First, before I begin, would someone please care to tell me what is a taxonomy? Somebody. You just did the homework, right? What is it now?
The flow, how is
the flow.
How we approach the project.
How you approach the project. Okay. Anyone else have an idea about what taxonomies can be?
And how my project is divided. What's my final project? How it leads to. Like, what's my final result from starting.
Ah.
Basics.
Did you get that definition from the lecture? Because I don't think that was in the lecture. You can interpret it in this way, but I would like to say that that is not the way I intended taxonomies to be interpreted. Does somebody have an alternative representation, an idea of how to describe a taxonomy? Have you heard of a directed acyclic graph? Does anybody know what that is? How did you do this homework? I'm astounded. So there is this idea about what a taxonomy is and what it isn't. And what it is it's a means of organizing items into classes and subclasses. So if you think about object-oriented programming with classes and subclasses, class refers to classification, and subclass refers to subclassification. So if you think about it, animals comprise a classification. A subclassification is mammals. A subclassification of mammals is humans. A subclassification of humans is irate professors who don't understand why the students think they did the homework but don't understand what a taxonomy is. So what we can see is that the number of irate professors is greatly dwarfed by, let's say, the number of humans. And so one can make a compelling argument that subclasses have a cardinality, which is the number of elements in the set, which is smaller than the superclass. And so the parent class subsumes the subclass. And this is what a classification system does. And that's how taxonomies organize knowledge. So I'll show you an example from the homework of some reasonable taxonomies and some which are just blatantly wrong, not taxonomies. Now, an acyclic graph is an interesting term. It's a term of the field. What field is it a term of? What field is that? Acyclic graph. Have you never heard the term before? You have. So where did you hear it? From me. From someone other than me. Someone not me. Have you heard the term before this course? Have you ever had data structures? Yeah, in data structures, did they talk about graphs and search trees? And so if you think about a directed acyclic graph, it is a tree, is it not? So trees are trees because they don't have cycles, right? The leaves are not connected to each other. And because the trees are generally inverted, right? They put the root at the top and they put the leaves at the bottom. That doesn't make it any less of an acyclic graph. The leaves are still not connected. So when you build a tree, you're building a directed acyclic graph. What makes it directed? What is the difference between a directed graph and an undirected graph? If you have an arc in an undirected graph, there are no arrows. If you have an arc with a directed graph, then the arrows only point in one direction. So that means that if you're in a superclass, the arrows point down to the subclasses. And then in the subclasses, the arrows point down to their subclasses. And this makes the direction clear, right? So an acyclic directed graph is a tree. It is, in fact, a tree is a kind of acyclic directed graph and can be used to represent taxonomies. True taxonomies do not have cycles. They are straight classification systems. And when you organize knowledge, or organize your slides, or organize your outline, you're not going to have cycles. You're going to break up the outline, you're going to break up your slides, you're going to break up your paper into chapters and subchapters and subchapters, maybe. So if you think about it, your outline is also a representation of a directed acyclic graph. So then someone said to me, what software should I use to make a directed acyclic graph? And the answer is, I don't care. Use Office, use Word, use PowerPoint, use OpenOffice, use a paint program. Get creative. Google it. Right? I mean, it doesn't matter. At the end of the day, it ends up having to be in a Word document. So if that's, or in some kind of a word processed document, even if you don't, Word is not a requirement for this course. If you don't have Microsoft Office and you said to me, well, Professor, I want to use AbiOffice, or OpenOffice, or StarOffice, or LibreOffice, or LaTeX, I don't care. Have whatever you want. In fact, I'd like it if somebody would change from OpenOffice, or Office rather. You don't have to use Microsoft products to get by in this world. But it seems like everybody else thinks you do, so maybe that's why everyone does. So I had this idea that we would look and see what some of the taxonomies look like, and maybe even some of the other projects. And here's one. That's very nice. It's a detection. There are different kinds of detection: thermal, metal, alcohol, gas, and radiation. That's a way. And then there's another taxonomy, different kinds of sensors: optical, electromechanical, mechanical, chemical, magnetic, and fluid. And then different kinds of data transmission. There's more than one hierarchy here: wired or wireless, telephone or Zigbee or Bluetooth or GPS. I don't know what GPS is. What is this? Gaussian. I think they mean GSM, right? GPS. GPS that's Global Positioning System. Is it a wireless transmission standard? I don't think so. They must mean GSM. Yeah, GSM. Not GPS. GPS lets me figure out where I am when I'm lost, which is often. So that's interesting. We had multiple taxonomies here. That's legit. Some people took a little time to write about the different taxonomies. That's important. Just a picture may not be sufficient, especially when you look at something like this and go, why are there 3 taxonomies? See if someone else has a nice taxonomy we can look at. I like the idea that we should all see what we're doing here. So somewhere in here we should see a taxonomy. Oh, see, now this is not a taxonomy, right? Why? This is a flow chart. This is showing flow. This has cycles. This is definitely not a taxonomy. So the person who did this, are they in this room? Who did this? You don't want to admit it. You know who you are. Oh, Jeff is not here. Okay. Yeah, that's not a taxonomy. Is there another one in here that is a taxonomy? Not a taxonomy. Oh, now that is a taxonomy. Right? This is pretty. So we have communication, broadcast or switched. Actually, they're switched and unswitched. Those are the two kinds of communication, switched and unswitched, right? Data packet switched networks, those are the ones we use for computers, right? Virtual circuit switched networks, they're the ones we use for modern telephony, like when you pick up the phone, not Skype. If you want to use Skype, then you're using a data packet switched network. If you want to use a regular telephone, there you pick it up and you get a dial tone, that's a circuit switched network. In the original embodiment, you would pick up a transceiver and then you would dial with an operator, and you turned a handle, a crank, and the crank was connected to a generator, and the generator created 90 volts, and the 90 volts went down a 3-mile copper twisted pair to a central office, and it would cause it to ring, 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 and the operator would pick it up, and the operator would say, "What number, please?" And then you'd say, "I want Murray Hill 7329." And Murray Hill would be the geographic location of the central office. And she'd say, "Just a minute," and then patch you into the central office, ask the other operator to hook you to the extension. Their other line would ring. This would take time, because a physical patch cord had to be put in, and a request had to be originated from the central office. And then you had a solid connection between your station and their station, and you could have a guaranteed quality of service after the setup time. That's a circuit switch network with a real circuit. Now they use virtual circuit switch networks, still with a guaranteed quality of service. Two kinds of networks, unswitched and switched. So this is not strictly correct. But broadcast is another way to go. So then under switched networks, they say circuit switched or packet switched. Well, that's not correct either. Oh well. But at least it's a taxonomy. It may not be a correct taxonomy, but what are you going to do? So then under frequency division multiple, we have polarization, modulation, amplitude modulation. Amplitude modulation is not an example of frequency division multiple. This is all messed up. Yeah. Got to say, "Hey Jeff, who is this?" All right, maybe that wasn't. Was this Jeff? Yeah. "Hey Jeff, not correct." We'll go to the next one. Someone's got to have a good taxonomy in here. See this? This is not a taxonomy. This is totally wrong. Thank you for playing. Next. Someone has this right. I'm convinced we've seen some good ones. See this? This is looking like a taxonomy. Oh, no, sorry. He's got loops. Not a taxonomy. Thank you for playing. Next. Geez, it's amazing how few people have got this right. Okay. Now we've got a taxonomy for transmission, wired or wireless, Zigbee or GSM. Transmission of data for short, or transmission of data to send a message? This doesn't seem correct. What is that? I don't even understand that. So, I mean, he was doing great until he put in this loop down here at the bottom. These two are now connected. And so now it's not looking like a taxonomy anymore. You all can see that. Come on in.
Which two?
Right? Because you see Zigbee and GSM are both connected to the same line going down. And then it says transmission of data for short, and then it says transmission to send message. So that's a loop. Right. That's not allowed. That's not a taxonomy. Taxonomy should be an organization. And this is not organizing. It's coming close, but it's not correct.
Because both Zigbee and GSM are able to do both of those functions.
Yeah, but you see that's not organizing the different data modes. So this is looking like a taxonomy. Computer programming for sensors, but it's unfortunately, well, let's see. Let's think about this. How can we program the sensors? either with artificial intelligence or tactical or executive or strategic. This doesn't make sense because then under artificial intelligence it says IR sensors. This should be an AKO hierarchy. That's a kind of. And an IR sensor is not a kind of artificial intelligence. So it's not a subclassification. So the person who did this, are they in this room? No? I say they didn't understand what the problem was. They didn't understand what taxonomies are. Shall we try another one? Somebody has to get this right. Let's see if we got someone else with a taxonomy. No taxonomy here. Ah, here we go. So, taxonomy for MIMD parallel processors. We have general computers, serial or parallel. In parallel, it's static or dynamic. And with static, it's SIMD or MIMD. And with MIMD, it's multiprocessor MIMD or multicomputer MIMD. And then with multiprocessor, it's UMA or NUMA. And with UMA, it's bus or switched. So this is a very good taxonomy of computing. This is correct. You can see how this has been organized. It's different. It really is different than what we've been seeing. Let's see. So we got somebody who got it right. A+. Are they in this class? No? Did the people in this class do homework? Oh, no? Really? Nobody did their homework? Really? This is terrible. Did you get stuck? Oh, here we go. Well, I can't read it. Can we zoom in or something? How does one zoom in here? I don't know how to zoom.
Can you just make it bigger? Just drag it from the corner.
Oh, I see. Wait. Here we go. Man, that's difficult to see. You guys can see this from the back? No, it's terrible. Who can stand it? It's very neatly done, but it needs to be reorganized because it can't be seen. You have to be able to drag these things around, you know. This says healthcare system, informatics, technology, and healthcare. Technology is not a kind of healthcare system. It's not, strictly speaking, a taxonomy. Although semantically incorrect, the organization is very nice. So I would take off points for it being semantically incorrect, not a taxonomy. Let's go to the next one. I hope we can find another person here who's done their homework. Oh, what a beautiful font. Isn't that nice? That's you? Oh, you do a beautiful font.
I'm not sure after all the discussion at the time.
So where is your taxonomy?
Next page.
Is it off to the right somewhere? Holy mackerel.
Yeah,
What did you do? What is this?
I hand drew it, so it's not that organized. But you can see modes of travel on the top, and then it's going down. And then motorized vehicles would be traveling down. Where I think I have a problem is where I connect like the three types of cars into one thing. You said that was a loop off to the right.
Oh. Yeah, okay, so let's see. Modes of travel. Plane, train, physical. Is physical a mode of travel? What would be like an ethereal mode or like an eclipse of consciousness where I see myself from my corner of the room and I can see, there I am looking back at myself. I have traveled into another plane of consciousness. I did this once when I did a lot of paperwork this morning. I did so much paperwork, and then I stood up, and it was like I got lightheaded, and I was in a different plane of existence. And then I realized I just stood up too quickly. This is what happens when you do so much paperwork. It's like you arrive.
Yeah, this is just the first draft version, I would call it.
So you have non-physical travel. I'm liking this. How do I do that?
Something like motorized versus non-motorized.
You know what's nice about non-physical travel? No bed bugs. No infestations. You don't have to clear out the luggage. Get these ones out of here. Oh my God! Look what came out. Yeah, that's what we need. Non-physical travel. You know, I think Virgin Atlantic would make a lot of money on that. You could just stay home.
It's all in the market.
Oh, they call it a staycation. That's non-physical travel. So we have different kinds of cars, fuel and hybrid, which are not fuel.
Well, we have
hybrids use fuel, don't they?
Yeah, but I wanted to emphasize the fact that you have just a normal. I mean, I could have gotten into more detail.
I don't feel that going into more detail will help you. In fact, I think you may have gone into a little too much detail. So if you said there are two kinds of cars, right?
Yeah.
Those that use electric and those that don't.
Yeah.
Then you'd be okay.
Okay.
And then hybrids would use electric.
Yeah.
Right? And maybe all electric cars would use electric.
Yeah.
So of the electric cars, you would have hybrid and pure electric.
Okay.
And so then if you
had,
fuel in fuel-based cars, you could say there are several different kinds. Those that use diesel, those that use gas, those that use CNG, those that use LNG, those that, have. What you've done here is not a taxonomy. And going into more detail will do you no good.
Okay.
No good at all. So you're trying to get categories and you're trying to subcategorize them.
Yeah.
So you need a classification system for your. What is your thesis?
My thesis has to do with going through the data, pulling out the best mode of whatever is the most efficient way of recapturing energy when a vehicle is placed in stop-and-go situations.
So energy recovery techniques include flywheels.
Yeah.
So there's mechanical,
Yeah,
and then there's supercapacitors. There's electrical.
Yeah.
So there are two different kinds of energy recovery techniques: electrical and mechanical. And then there may be another one that is chemical. I don't know. You could have one where you take the energy and you convert it into hydrogen by breaking through electrolysis. I don't know. But probably commonly there's electrical and then there's mechanical, and that's it.
Okay.
For recovering energy.
Yeah.
This other thing with the buses and the scooters, I don't get.
Well, just different forms of motorized vehicles. The thing is, there's in different materials I've been reading, there's a lot of emphasis put on trains.
And capacitor is spelt wrong, isn't it?
It's very possible.
Yeah.
Once you finish typing it, the only way to edit it is to erase it and retype it.
Oh, so this is a bitmap.
This was done in Paint, yeah.
Oh dear. Well, there's a compelling argument against using a paint program for your.
Yeah.
There are.
It was good on the fly, just to see where my ideas are going to take me.
Are there any more? That's it. So I only had a dozen at the time I opened this up, which was a few minutes before the class began. Presumably you've all submitted your homework by now. Or not. So that was it. I only had 12. But clearly more people than 12 would have done this. Right? I'm thinking. Right? Who here did their homework? Only 2? Nobody else does homework? You graduate students? You don't do homework? Do you know homework counts for third. Did you know? You knew that, right? A third. And your midterm counts for a third. And a lot of times if you take your homework and you do it well, you can put it in your midterm. Right? So if you have something in your midterm called problem statement, well, guess what? That was a homework. So the same thing happens with the final. The final is going to want to have the taxonomy in it. So if you don't do the taxonomy, it's going to be missing from your final. So it's like you got counted twice for the same work. So you might as well get it done now, because otherwise, you know, you're going to be wanting to have it finished by the time the final is ready to submit, because you need these things. This homework is not here to punish you. It's here to help you. Right? I'm not here to ridicule you by going through your homeworks and saying, "Ew, look at this taxonomy, it's not correct." No, I would like you to be able to learn from this and to try and come up with, you know, an idea. So tell me now, what shall we do? I'm thinking maybe we should look at this taxonomy thing a little bit, and maybe for a good time we can try and do a little taxonomy on our own. I think there's a nice way to do this. Under design, I can pick a design. Perhaps we'll pick one that's kind of blank looking. Let's pick a design. I guess we can make our own design. Oh, there's one. I want a nice plain design. There's one coming right here. I like this. Very nice. And what we'll do is we'll try and do some kind of graphic. Now there should be a way to insert drawings here. And here's this thing here called shapes. And so what we'll do is we'll create a nice shape, and I'm thinking we could start off with squares, and we'll just organize things nicely, and I'll copy and paste the squares to get a similar size. In fact, I think it might be fun if I just did copy, paste, 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 and I'll organize my hierarchy so that it'll pack the different things together. So what I'll do is I'll try and create a nice looking organization, and then maybe I'll connect it with my directed acyclic graphs over to here, and maybe, is it possible I could just, I would like a better arrow. But I guess maybe I gotta format the arrow. Connector type. Curved connector? I can do that. That's good. Actually, I like that. We'll do another one with a straight arrow. That'll go from here to here. And let's see what other kinds of fancy arrows we have. Here's something called a line. That works. And we can do another one which goes from here. And now, is it possible for me to draw a line from any other square to, let's say, this orphan over here? Like, can I go from here to here? Is that still a hierarchy? Am I still in a taxonomy? Yes, one parent can have multiple children. That's legit. So now what we'll do is we'll identify some text that we can put in here. Let's see now. You said something about energy recovery. That's right, isn't it? So there are different kinds of energy recovery. So let's just abbreviate it ER for energy recovery. Or maybe I can spell it out. Energy recovery. So what kinds of energy recovery do we have? Well, I was thinking that maybe there would be mechanical.
Jay said mechanical.
Well, I'll just write mech because it doesn't quite fit.
Electrical.
And then we'll have non-mechanical, right? Non-mechanical. Non-mechanical. And so in mechanical, the one thing that I think people have in common for mechanical energy recovery might be something like the flywheel. And for non-mechanical, I could probably do something involving electrical. That's not mechanical. Or what would be some other way? Yeah, is it possible I could do something with energy recovery that is, how would I do it with chemical energy recovery? How does that work?
You could imagine something having to do with, I keep thinking mechanical is getting in the way. At some point we need something there. But you could have simple.
How about gravitational? But is that mechanical?
Yeah, like you'd have to have like a gyroscope or something you're talking about, right?
I was thinking about coasting.
Okay. So
Right? So that's not exactly, well, maybe it is mechanical. By coast, if I go down a hill and it's steep,
yeah.
right, and I don't use the brakes,
Yeah.
then when I go up the next hill, it carries me forward because the kinetic energy is being converted into potential energy. And then as I get over the next hill, I might only need very little extra power to get over, and then I can go down again like a roller coaster. So that's kind of using gravity. So it's not a pure, is it mechanical? It's kinetic. It seems mechanical. You're trading potential and what would be another way to do energy recovery in a car? Maybe you don't have anything else. And if that's the only common thing, then delete it. And if that's the case, this doesn't belong, and you're done. That is a perfectly legitimate taxonomy. Right? It's either mechanical or it's not. And in mechanical, we use flywheel. Maybe we could say and gravitation. Gravity for coasting. I'll put that in there if you want. Copy, paste. I'll put that over here. And then we'll change that to, I'll change it to coasting. Coasting is a legitimate way to do energy recovery. I think we do this ourselves, right? A lot of times I find myself going down a hill, I don't use any gas at all, and I try not to use the brake. I let my car accelerate until it's dangerous, or I shouldn't. And then when I go up the next hill, I train my kinetic energy for potential energy. Then I let the car slow down a little bit until I feel like I need to use the gas. So then that's coasting. That's energy recovery. Very low tech. Very effective. Very efficient. Right? You probably do it all the time if you're on a bicycle. Right? If you spend a lot of energy getting up the hill in your bicycle, and you're at the top of the hill, man, you're sitting there on so much potential energy, and you want kinetic energy. You go down the hill, you try and go as fast as you can without being unsafe. And then when you go up the next hill, you let that energy carry you forward. Right? So you intuitively do this. Right? So coasting is a perfectly legitimate mechanical way to do energy recovery. Now, if you think about it, the set of all different energy recovery systems has now been divided neatly into two different subsets, mechanical and non-mechanical. And for non-mechanical, the only one we know is electrical, because we couldn't think of anything else. And for mechanical, the only two we know are flywheels and coasting. And that's it. Now you could say, but wait, Professor, you forgot about springs, or rubber bands, or something else. I don't know, you want to build a car with big rubber bands, it's probably not a car that you will drive, but it could still be a reasonable car. I've had these little friction cars where you pull on the wheels and then they go when you let them go. So that's good. You can have a spring, especially for a toy. Why not? Toys store energy, right? They call them friction cars. That's legitimate. So I say that you didn't need more detail. You needed less detail. This is good. You do this 100. That's all. That's it. You got another one for me? No? No suggestions? Go ahead. Don't be shy. No? Really? Okay. I think people are very shy in this classroom. All right, so does everybody now understand about taxonomies? This is very important. It's going to be in your final. You're all going to have to do it. And there's something else that I've been holding off on until I felt like you had your midterm under your belt and you were ready because you had thought about your problem, and that is your presentation. One of the basic outcomes of this course is good communication skills. That is both in oral presentations and in writing. How many people here have done an oral presentation before? Only 1, 2, 3, 4? Okay, how many people feel a little nervous about it? It's natural. It's completely natural to be nervous. We're going to do this so that we all listen to each other. You're in a, non-pressured situation. You know everybody here. We all know each other by now. We're going to go through a process whereby we are presenting to each other and we get comfortable with the presentations. And if you're nervous, you're going to get over that nervousness. And it's going to be done by virtue of repetition. We're going to be doing presentations, and I'm thinking that it's going to help us hone our presentation skills. It's very important. So what I'd like to do is discuss a little bit about what it's like to put together a reasonable presentation with PowerPoints. Now, some people might say, I don't want to use PowerPoints. Who here wants to avoid using PowerPoints? No? You're all going to use PowerPoints? Okay, that's fine then. We'll do it with PowerPoints. Shall we save? No, don't save. You don't want to use PowerPoints? Huh? I got some pushback on the PowerPoints back there? No? Okay. I'm not convinced that PowerPoints are the best way to do a presentation, but I do know they're the most common. Easily the most common. Over the last few weeks, I have been throwing away all of my old plastic overhead projector slides. I kept them in my attic for no particular reason. These things. You guys ever see these things being used? The overhead projectors? They're common. They used to be used every day, but I haven't used them in years now. And I kept all my old slides because I'm a pack rat and I never throw anything away. I store it in the attic, and there it was, all these old plastic slides. So I thought, well, maybe it's better this way because A, you get color more easily. It's cheaper to do color. If you had color for overhead projectors, it was considered a novelty and expensive. Also, I think it's nice because those slides are terribly expensive. Very expensive. Because they're based in oil. And plastics, they come from oil. And so engineering plastic is directly linked to the price of crude. As I think about it, PowerPoints are also infinitely revisable, like a word processor. Whereas once you print your overhead projector slides, they're immortal. You don't feel like changing them. So then I thought, well, there's something else about PowerPoint. You can send it electronically. You can share it with your friends. You can transmit it to your boss. You can have it revised by others. And so that becomes very important as well, because now you have an opportunity to go out to the writing center with your PowerPoints. And your PowerPoints, they somehow need to reflect the thesis ideas without being detailed. In other words, if you had an abstract, it would be strictly incorrect to take that abstract and paste it into your PowerPoints. Really wrong. I would take off big points for that. because it meant you didn't really think about the PowerPoint. Some people say, oh, it's very hard to convert Word into PowerPoints. Yes, that's true, because you have to think about it. For every single point that you put in, you're using valuable real estate space on your PowerPoints. And one of the things that I like to do, which I think is so important, is that the PowerPoint contains perhaps one word per bullet. Just the basic idea. That's enough. And then you can talk to that idea. You don't need a script. Right? Do not write a script out. But do think about the basic points that you're going to put into your PowerPoint. That's sufficient. And if you read, heaven forfend, you read, for existing PowerPoint users, this workshop will examine various guidelines for creating better presentations, including guidelines for text, color, graphics, and interaction. Your viewers will think you are a bozo. You know what I mean when I say that? Bozo, a clown. They think, oh, he doesn't even know the material in his own PowerPoints. And the first thing they'll do is they'll say, oh, he's reading it. Well, I can read it. I don't need anybody else to read it to me. That's ridiculous. So I figure I'm not going to insult you by reading it. And I also am really beholden to this idea that you don't need me to read this to you, because you can read it for yourself, and that's sufficient. I love the idea of organizing by taxonomy, organizing by outline, organizing by taking the basic ideas that you plan on covering, tell people what you're going to cover, then cover it, and then tell them what you covered. So tell them what you're going to tell them, then tell them what you told them. Right? Wrap it up, summarize it. So as I see it, there's a little bit of repetition in there, but it's also part of organizing the material properly. When you organize the material using an outline, you're building a taxonomy of sorts. It's a directed acyclic graph, because you'll never have a cycle between a subsection and another subsection. So it will force you to organize your material. This is the pitch, right? Pitching. This is American baseball. Do people play American baseball here? No? Pretty good. You play cricket. Do you play cricket? It's just like cricket, only I think there's something different about it. Oh, the bat is different. Bases. Do they have bases in cricket? I know nothing about cricket. You tell me. Do they have bases where you have to run from one base to another? They do. They have bases.
Did you ever play running bases when you were a kid, where you just go back and forth like monkey in the middle?
Yes.
That's more like cricket.
Is it?
Yeah.
I've never played cricket. I don't know it. I used to play water polo, but I had to stop because my horse drowned. So there are, I would call them tips or techniques for using PowerPoint. Let me see if I can do this. Aha. So what I'm going to do is I'm going to run through some of these slides, and then where it says your turn, we're going to try some of the things that the slides are suggesting. And so there are these techniques which you can employ when you go to design your PowerPoint presentation. And one of the techniques that you can employ is the use of a template. And another one that you can employ is the use of a master slide. Is this boring? You guys know this stuff already? No? Okay. Good. So maybe we'll all learn something together. I find that this becomes what is perhaps the most tool-oriented of talks, because we're teaching you more about how to use the tool and less about, the conceptual stuff that's going to stick with you. But if you're going to use PowerPoint, you might as well use it effectively as a tool. And one of the things you want to do is get a consistent theme that runs through the PowerPoint slides. And you want to be able to organize and manage those themes appropriately. Sometimes people say that PowerPoint slides should be something like 10, 20, 30. Have you heard the 10-20-30 rule before? What does it mean? You know?
I don't know exactly, but it's something about the amount of slides, words on the slides, and how long you spend.
Yeah, 10-20-30. So it's 10 slides, 20 minutes, 30-point font. Yeah, so that means that when you're in the back of the room, you can read it comfortably without squinting. Can you read this comfortably from the back of the room without squinting? I can read the top title, and my eyes are bad. Well, it's a little fuzzy for me, but I can certainly read it. It's probably better if I turn out the lights, but then you'll all be sleeping. Me personally, I think I would prefer 48-point font. But you know what? Younger eyes can see this more easily. Does anybody else see this as fuzzy in the back of the room? No, it's clear, huh? Oh, see, I need glasses, but I refuse to wear them. So what I thought would be good is if we talked a little bit about the techniques of how to organize your slides, figure out how to deal with the design, and then go into the low-level questions of how to deal with the formatting of text and the creation of graphics. So those two elements are what I would call detail elements, but the most important thing, top-level thing, plan it. Plan your design, plan your slides, your layout, what it is you want to say, then deal with the design as an overall thing, and then start to work on the text and the graphics, the detail, filling it in. So planning. I would say you have done a lot of planning already. You've already got an introduction, and the introduction consists of a problem statement, a motivation, and there's probably some ethics in there as well. The more detail will probably come in when you do the approach, right? So when you start to think about the approach, there's something about the approach that has to do with the design of an experiment. What makes a good scientist? They ask the questions that nobody else thinks about. Maybe it was Fraunhofer who was in the Institute of Optics, and he looked at these spectral lines, and in between the spectral lines he saw little black patterns. And he said to himself, why is that there? And then he was able to deduce, after designing some experiments, that it had to do with the chemical composition of things. And he devised a technique called spectroscopy, right? Something we take for granted today was devised by a scientist who said, why is this here? How come that looks like this and this other thing looks like that? And with spectroscopy, he was able to devise the chemical compositions of galaxies he could never visit, or that we would never visit, not in our lifetimes. And the chemical compositions of different stars and different planets. And he was able to do these things because of the spectroscopy that he discovered. Right? So when we think about it, he came up with an approach to design this experiment. And he said, well, let's try a control. Let's try a thing that we have an idea about what it's made of, like fire from paper. And then let's figure out what it's like to have, let's say, fire from gas. And maybe we'll just look at the spectra and see why these things are different. And so he designed an experiment, part of his approach, right? So I would say the most important thing when you use the scientific method is to design your approach to validate the hypothesis, right? Enrico Fermi said, if I conduct an experiment and it validates the hypothesis, I have collected data. But if I conduct an experiment and it invalidates the hypothesis, then I have made a discovery. Right? So you need to be able to conduct experiments that might possibly invalidate your hypothesis. Right? You have to design a test for your hypothesis, whatever it may be. And so then we want to hear about your plan for your experiment, as it's a part of your approach. Somehow, your thesis is going to have a little science in it somewhere, and I don't know where it is, because it's your thesis. But we'll have a plan, and you're going to have to describe that plan, and you're going to have to describe the experiments, and maybe some of the experiments will fail, and you won't be able to validate your hypothesis, and you'll have made a discovery, and that's okay. In fact, it's great. So I know that it's not easy for you to think in terms of a full-blown thesis because we're only doing a thesis proposal. But we need to sort of plan away the ideas of how we're going to do these experiments, how we're going to allocate resources. That's our time, that's our effort, that's any capital equipment we may need in order to conduct the experiment. And if somebody said to me, well, I'm going to build a robot that's going to bring me my beer. Well, maybe there are capital resources needed in order to get a robot with a manipulator. And probably you'll find a way to get yourself a beer. And between the two, you may also say, gee, you know what? I need a course in image processing because I don't know how to recognize a beer. And that, of course, will factor in to your desire to create this thesis. And say, I want to do a thesis, but I can't do it next semester. I got to take a course in imaging. Well, that's fine. Or you might say, I want the smart camera from over in the tech area because the smart camera lets me recognize a beer without having to program it. It uses the LabVIEW system, which is a data flow system for doing visual programming. And it's not just about hardware. You might say, I need a special toolbox from MATLAB because I want to do my thesis on financial data mining. So I need the financial data mining toolbox. And I'd say, fine, we'll get that for you. And we may have to allocate money, and that's all right. For a thesis, we would do that. It's part of your education. And then at the end of the day, you have to give us a preview. Your preview will say, I plan to be able to collect some data that will show the following. And then you could say, here's a sample of the kind of data I expect to collect. And it could be a chart. It could be a graph. And I plan on making this graph with real data. So that preview, this is what I expect to obtain when I do the experiment, however much overhead there may be in the experiment. I like the idea of using a storyboard. How many people know what that is? You ever hear of a storyboard? Storyboard, it's like a comic strip where the different actors and scenes are sketched out, one little storyboard subsection after another. You know, the comic strips, they're just little pictures that are trying to depict action. So that storyboarding is something you could do perhaps with a pencil and paper. You don't need PowerPoint for this, but PowerPoint can help you. And so the storyboard gives us kind of this outline of, well, here's the subsection in here, which will have the title, and here's the one with the outline, and here's some graphs and some charts, and a couple of slides of explanation. Bang, I'm done. What would the hierarchy be? It says create a hierarchy. What would the hierarchy be? It's not necessarily a taxonomy, but it could be a directed acyclic graph. So it's like a taxonomy. So the hierarchy could be, well, here's the whole thing, and then here's the sub-chapters. Introduction, maybe approach, historical review, perhaps literature cited. And then underneath the introduction, you might have something like problem statement, motivation, ethics. And then underneath the approach, you might have something like experiments that we plan to do, predicted results. And then under the historical survey, you could have a taxonomy. And the taxonomy could say, well, there's two kinds of sensors, passive and active. And there's two kinds of passive sensors, those that use optics and those that don't. And there's two kinds of optics, passive sensors that I know about for my area, which is 2D and 3D. And there's two kinds of passive 3D sensors that I know about. Some use binocular vision systems, like triangulation, and others use, let's say, diffraction range finding. You can do 3D range finding that way. So you can just divide up all the different sensors. And then for the active, you can say, well, there's sonar, there's lasers, there's, all these different other actives, radar systems, all different kinds of 3D active systems, right? Because radar systems need a ping, sonar uses a ping, but sonar and radar are kind of different because sonar uses sound and radar uses radio, but otherwise they're both active sensors. They both require a ping. So I could categorize them in that way. So they're both active. They're both 3D. So now I've got this wonderful taxonomy. It goes into my hierarchy. Perhaps it's organizing all the papers that I've read. Sometimes I look at these midterms and I say, gee, here's the literature cited, but nobody has written anything to cite it. So it's not literature cited. It's literature uncited. What happened? This is a readings course. How could you not write something and about the literature you've been reading? At the end of the day, I'd like you guys to have something on the order of 25 or more papers and cited, which means you're writing about them and organizing them and trying to figure out where they all contribute into your thesis, because they're not just papers, they're relevant papers. They're papers that matter. I don't need you to read papers that don't matter. You will have to read papers that don't matter. No question. You will not be able to cite every paper you've read because it will not matter. And it won't make sense to cite it. That's fine. It is a readings course. You guys are supposed to be reading. How many people aren't reading? I know there are a few of you out there. So now the question is more, I'll call it tool-oriented. How do we proceed with the design? I'm really liking this design because it's simple. I find simple is a feature, especially in PowerPoints. Especially when PowerPoints enable you to make it so that every single character can have a different font. Do not do that. Right? That's so bad. If people start putting down really wacky looking designs that just are totally outlandish, it distracts from the ideas. It distracts from your talk. It makes your presentation seem too petty, in my view. So you can try these different designs, but I would stick to something as simple as it can be, if not simpler. So here's two examples. Design, right? This is a color choice. I've got blue on black, right? Blue on black, or white on blue. Well, for better contrast, I like the idea of having something that's, got a very dark color versus a very bright color. In that way, it makes it more readable. So even if the fonts are a little bit smaller, if you have good contrast, you can see it better. Blue on black, it just looks to me like it's a dark color on a dark color. Not a good idea. So I like a white background with black. You could probably do a black background with white. What's a serif? It's a serif font is a font that has bezels on the edges of the characters. A sans serif font is one that does not have those bevels. So if you look at this font behind me, is it serif or sans serif? Sans serif. These are nice straight characters. I think it makes things a lot simpler. If you look at all of the old standard definition characters in the credits for television shows, they're using sans serif because they don't have the bandwidth to do the serif fonts. What's a slide master?
Master slide.
Yes, it's a master slide that allows me to govern the behavior of the entire slide deck. So it should be possible for me to look at a slide master. It's right over in here. Go to the slide master, and now what you can do is you can go to the bottom and you can do something like put in a footer that is consistent for every slide. That'll be duplicated on every slide. And this footer could say something like IACT201408. And now maybe what we can do is go back to the original slide and see if it appears anywhere. It does not. Why not? I get the wrong let's try this one. ECE420. One of them should have it. Apparently it's none of these. Wow. Let's try this one. ECE420 and go out. See, it says the Cane Project, but there's no consistency. I've got one more idea. I'll try this. ECE420 and back. Nope, didn't apply. So that didn't work out. Let's see if we can try a different template. I will view the normal view, and then what we'll do is we'll go to the design area and we'll change the template. And there, it's changed. You can see it's got a halo around the edges. It's the same slide, different template. It all starts with getting started. And there's more templates here. I find that very difficult to read, and I'm right on top of it. For some reason, that's a little easier to read. Maybe it's because of the color. That fluorescent orange color is helpful. Let's see if there's another one. I like the big red font in the front. That seems to work. This one seems very dark to me. So picking the right design and then having it consistent so that you can stick to it throughout the presentation. That seems like a reasonable thing to be doing. Here's a bunch of these. And you can load new ones for whatever reason you might want to. So for example, look at this background. It doesn't seem correct, right? It's too hard to read. Why? Because it's black on blue. So what would you do? Huh? Say it again? Yeah, change the color. I mouse right, and I can format the background, and I can change the background color to, well, perhaps something a little brighter. Apply to all and close. And now maybe it's a little bit more visible. What about this business about the font? How can I change this font, huh? Mouse right, format shape, and is there something in here for fonts? I'm not seeing it. Mouse right again. Oh, here it is. Yep, there it is. So I want this to be something a little larger. Let's try 30-point font. And now we've got our choice of fonts. We'll try, let's try a sans serif font. I know one called Palatino. Actually, this might be a nice font. There. That's a nice font. So, all the city fonts, Geneva, Chicago, they're all sans serif fonts. Courier is a sans serif font. Other sans serif fonts like Helvetica and Arial, they're also very good. Let's see if I can get us. Times Roman is a serif font. It's very good for printing on the page. And Times is an interesting font because it is a standard font for the Typesetter Association, which means you can find the font installed on image setters. Image setters output onto film. Clear film is then used to image what's called a plate. In printing, the plate is sensitized with a photographic developer. And then what you use is very high intensity ultraviolet light, and you shine it onto the plate through the film. And this is called photolithography. Then you take the plate and you etch it, which means you put it in an acid bath that etches away the copper. And then you use the plate on a printing press, and where the pits are, that's where the ink will adhere. Bubbles of ink will then be imprinted on top of the page when you are in the printing press. And so you might do this for the 4 color plates, cyan, yellow, magenta, and black, and use the 4 different inks on the 4 different plates. And then when you go to press, you must align the plates so that they will be registered when you go to create the rosettes. Okay. You don't use an International Typesetter Association font for your PowerPoints, right? Because in general you're not going to press with your PowerPoints. And that's almost always true unless you're doing a book on PowerPoint, in which case it's not true and you should use an ITA type font. Courier is a sans serif font, which is an ITA type font, International Typesetter Association font. So you can find Courier as a common font, type 1 PostScript font in all of the image setters. If you have a font and the font has not been downloaded into your image setter and is not a standard part of the image setter, it won't look right. The kerning will be wrong. Anybody know what kerning is? Never heard of kerning? Really? It's the distance between the letters. So interletter distances need to be adjusted when you design the font. And if the interletter distances are not correct, it just won't look proper. Is it time for a break? I think so. All right, let's take a little break. I'll stop this.